Okay guys, in this problem we are going to observe the following simply supported truss, and we are going to find the loads in members B and C in kips. So in this truss we can see that it is supported here, and members A, B, C, and D are called out. Additionally, all of the truss members are the same length, and we have 3 reaction forces applied at the following joints. So this problem is asking us just to find the loads in 2 members here. And we can do that with what is called a force analysis. And really all we are looking for here are 0 force members. Because if we look at the availability of our answers here, we can see that they are either 200 kips or 0. So we don't need to do any math. So we can do this problem just by inspection as well. And the way we can do this is by following 3 rules to determine if something is a 0 force member or not. So the first rule is if 3 members form a joint. The second case is if 2 members are what we call collinear. And what that means is they are in the same axis, the same vector, and the same plane as each other. And finally, if no external load or reaction occurs at that joint. So if you can meet these 3 cases, then the third non-collinear member in your 3-member joint is a 0 force member. So let's start doing this by inspection. We could start with A, but because we're not being asked to solve for A, I think we should go right to B. Now we can see here that B has 2 different sides, but we can only analyze B using the 0 force series of rules from this joint up here. So there are 3 members in this joint. 2 of the members are collinear. If 2 of the members are collinear, as we can see here, and finally we have no external load or reaction at this joint. We do have one beneath it, but we're looking at the joint at the top instead. So using our rules, we can determine that there is 0 force in member B. So what this implies here is that these other 2 diagonal members are taking the force of the applied load from the joint beneath it. So now that we've solved B, let's move on to C. We can see that at the top joint there are 5 members, so we can't solve member C from the top joint. If we go to the bottom of member C, we can see that 3 members do form a joint here, and 2 of them are collinear. However, Rule 3 is violated because there is in fact an external load at this joint. So we cannot say that this member here is a 0 force member. So even if we had not solved for C and we had only solved for B so far, we can already determine that 2 of these answers are wrong. However, since we have also solved for C now, we can determine that the third answer here is going to be our correct answer. And that's it for this problem. If you see a problem like this on the test, remember these 3 rules and you should be successful in solving it.